So, hi guys. Today's Leet-code problem is maximum difference between node and ancestor, right? So, given a root of binary tree, find the maximum value v for which there exist different nodes a and b, where v is equals to a dot value minus b dot value, and a is an ancestor of b. A node a is an ancestor of b if either any child of a is equal to b, or any child of a is an ancestor of b. Let us examine this condition here, like what this condition mean. So what is an ancestor here? So ancestor is, if we consider 8 as a, okay, and these a childs like 3 and 10 are equal to b, so a is an ancestor of b. So this ancestor is 8, and the nodes children, okay, the node childrens are the nodes children are uh, like like what we can say is, if we consider 8 as an a and the children are 310, right? 310 be the p equal to b, such that b, so 3 can be, 3 is the node and 8 is an ancestor here. Like in other case, any child of a, like any child of a, if you consider this as an a, any child of a is an ancestor of b. Like any child of a, this ancestor is, it can be ancestor, and if these children are nodes, so these can be ancestor, these children are nodes. Okay, from this we can say that the children of nodes are children, and the node is an ancestor, right? So so what are the ancestors here? For one the ancestors are 3 and 8, right? And for 3 there is an 8 here, ancestor is 8. And for 6, 3 and 8, 3 and 8. For 4, 6, 3 and 8. For 7, 6, 3 and 8. And these are the ancestors of 7, 4, 6, 3, 1 here. Now what we have to find here, find the maximum value v such that the absolute difference between node and an ancestor is maximum. Like we need to find the maximum value where the maximum absolute difference is, where the absolute difference is maximum, right? So for that, what we need to get? So for that, we need to get a maximum value and a minimum value, right? In that case only we can get a maximum value, right? So for example, there is a for example, there is an array. So for example, there is a 1 2 3 4 5 6 7 8. This is an array, and what is the maximum value between two nodes here? The minimum value and the maximum value, right? So the minimum value and the maximum value is the maximum difference here, right? So this is the maximum value between what the maximum difference between any two nodes, right? So in this way also we need to find the maximum value and the minimum value. Like we can consider any of them as ancestor and node, so we need to find the maximum value and the minimum value here. Like for suppose we are at 8 and this ancestor is itself 8, and the, like these like if we consider here, if we consider 8 and if we perform DFS over uh, this subtree, this tree, we need to find the maximum value, right? So if we perform a DFS here, we need to keep the track of minimum and maximum value, right? So initially the minimum value will become 8 and the maximum value become 8 only, right? If we go here, so example, if we, I will illustrate with this one here. So initially this is min and this is max here. Like initially there is an node 8 and this is the So this is the minimum value and this is the maximum value here. So we need to find the answer here, which is a global variable here. We can consider answer as a global variable here, right? Answer equal to 0 initially. Okay. So now what will be the answer? Like, what will be the answer? The absolute difference between node dot value comma minimum value and node dot value minus maximum value, right? So answer can be, we need to find the maximum, right? So we need to do maximum here. Maximum of answer comma math dot max of min minus root dot val comma max minus root dot val. If we do this for every iteration, we can find the maximum value as an answer here. Like for this node, the maximum value will become 0, right? If we, after doing that, we need to find the minimum and maximum value of the root. Okay, and we need to go to the left, like root dot left comma min comma max, and we need to also go to root dot right comma min comma max, right? So as a condition, as a statement here, we need to go to the left subtree, right? If we go to left subtree here, what will be the answer here? Answer of the left subtree will be, so answer of the left subtree is, answer is initially 0, and answer is initially 0, 0 comma min. What is min? 8. 8 minus 8 minus root dot value, it is 3, right? It will be 5. 5 comma 5, right? So now the, what is the maximum of 5 comma 5? It is 5, right? Now answer will become 5. Okay, 0 is 5 is greater than 0, so answer will become 5. So we need to change the answer here to 5. Okay, and we need to update our min value here. So what will be the min value here? So min value will become 3, right? 8 is lesser than 8 is greater than 3, so min value will become 8 3, and maximum will become 8 here. So we need to go to the left part again. Now we need to go to left part. So left part, there is a node called 1. So we need to find the answer here. So what will be the minimum here? Minimum is 3. 3 minus 1 comma 8 minus 1. What is the maximum here? What is the maximum here? Maximum is 7 here, right? So 7 is greater than 5, so answer will become 7 here. So our answer will become 7 here. Okay, so now we need to go to the left here. So after going to left, there is nothing anything. So we need to return here. From here we need to go to right. So we go to right here. So our value is 4 here. So initially there is a 7 here, and what will be the minimum here? So minimum will be 1 here, right? So 1 comma 1 minus 4 is 3, right? Absolute difference, right? And 8 comma 4 is 4, right? So maximum of these three is 7 only, right? So don't need to do anything here, 7. So we need to go left here, there is a null, and we need to go right, there is a null, and we need to return everything here. From here we need to go right here. The node is 6, right? So the node is 6, and we need to find the answer here. So answer will become, what is the minimum value here? So minimum value is 3, right? 6 minus 3 is 3, and 8 minus 6 is 2. And what is the maximum of these three? 7 is the maximum, so we don't need to do anything here. We need to change the minimum value here. So what is the minimum value from 3 comma 6? So it is 3 only, right? What is the maximum value between 8 comma 6? It is 8 only, right? So we did this thing here. Okay, and after going here we need to go right here, or else left. And after that, after going right here, after going right, the node is 7 here. So 7 minus 3 is 4 here, right? And 8 minus 7 is 1 here, right? So what is the maximum value between them is 7 only, right? So answer will become 7. After that, we need to do, we will be returning this all things here, and we get a value here. From here we need to go right here. So from here, when we go to right, there is a node called 10. From 10 we need to find the maximum of minimum minus root dot value, comma max minus root dot value. Minimum minus root dot value is 2, and a max minus root dot value is 2 only, right? From this 3 we get a 7 as a maximum value, so we answer is equal to 7 only. From here we need to go right here, which is 14. 14 minus 8 is 6, and 14 minus 10 is 4, and 6 minus 4 comma 7 is 6 comma 4 is 7 only, right? Don't need to change that value. We need, from here we need to go right, and here the node is 13. 13 minus 8 is 5, and 13 minus 14 is 1. From here, from these three we get the maximum value as 7, so we don't. So at last we can return the global value as an answer, and if we return, we get the our maximum value as answer. So the maximum value is in between the ancestors only, like ancestor and node only, not between any two nodes, right? So in this way we can perform this algorithm. This is an brute force here, like code here for doing this. This is the logic here we need to perform here. We need to perform a DFS algorithm here. So we need to go to left and right subtree. After going from left subtree, we need to go to right subtree here. We need to perform a pre-order traversal here. So what is the DFS algorithm we are using here? Pre-order traversal. So one thing, remember, every time if you find so every time if you come up with an binary tree or binary search tree solutions, like questions, you need to the the in maximum cases the answer will be between pre-order traversal or in order traversal or left, like this order traversals only, and it will be mostly in this DFS algorithm only, or else it will be in BFS algorithm, right? Nothing more than this. If you practice more pre-order traversals and level order traversals, in order traversal and post order traversal, you can get a grip of this. You can solve these kind of questions easily. And what you need to observe is, you need to observe the changes in the pre-order traversals. That's it. What is the changes between them, and if the changes is coming up to a right solution or not, we need to see this. In this way we can easily solve this binary tree solutions or binary search tree solutions. So coming to the code here, if you observe the code here, I've initially took the a minimum as root dot value and maximum as root dot value, and took a global value answer as 0, and called a DFS solution here, and return the answer here. The DFS solution is in turn the same as we discussed it. So if the root is equal to null, then return something, return null. So answer, in answer we are storing the maximum of answer comma min minus root dot value, comma, max minus root dot value, absolute difference, right? So we are storing this thing here. And calculating the answer, we need to store the minimum value, right? Minimum value between minimum comma root dot value, right? And maximum value we need to store there. Maximum comma root dot value. After calculating these all things, we need to go to the left subtree, and after calculating the left subtree, we need to go to the right subtree. In this way, we need to solve this problem. Right? And coming to the time complexities of this problem, this is a big of n solution, and space complexity is also a big of n solution. So that's it. Thank you.